In order to learn Chapter 9, you need to understand several basic things about circles. First off, what is a circle? A circle is a set of points in a plane, all at a given distance from a given point in that plane. The given point is the center of the circle. The given distance between any point on the circle to the center is the radius. All radii of a circle are the same length. Examples of circles can be found all over. One of the best things that illustrates the properties of a circle is a tetherball court from an aerial view. The tetherball pole is a lot like the center of a circle. The tetherball itself is similar to the infinite points that make up the circle. The cord binding the tetherball to the pole is the radius. Congruent circles are circles that have congruent radii. Concentric circles are circles that lie in the same plane and have the same center, but don't necessarily have the same radius. Concentric circles can be found in an aiming target, the bullseye being the center circle and the rings around it are other concentric circles. Now, this is when the polygons get involved. A polygon is inscribed in a circle, and the circle is circumscribed about the polygon when each vertex of the polygon lies on the circle. The opposite can also occur. When each side of a polygon is tangent to a circle, the polygon is said to be circumscribed about the circle, and the circle is inscribed in the polygon. Any polygon can be inscribed in and circumscribed about a circle. With that reviewed, we can move on to tangents. A tangent is a line in the plane of a circle that intersects the circle in exactly one point. This point is called the point of tangency. If a line is tangent to a circle, then the line is also perpendicular to the radius drawn to the point of tangency. In addition, if a line in the plane of a circle is perpendicular to a radius at its outer end point, then the line is a tangent to the circle. Tangents to a circle from a single point are congruent. There are also only two tangents from a single point to a circle. This ice cream cone is a good visual for a corollary learned in section 9.2. The two tangents drawn from a single point to a circle are congruent. The edges of this cone are like tangents from a single point touching the ice cream scoop. A line that is tangent to two coplanar circles is called a common tangent. A common internal tangent intersects the segment joining the centers of the two circles. A common external tangent does not intersect the segment joining the centers. Now, imagine two snowmen standing a few feet apart, placed on a seesaw. The bottom snowballs are like two circles touching an external tangent, the seesaw. You could also envision a clown pedaling a unicycle over a board balanced on a beach ball. I know it's a stretch, but just go with it. The unicycle wheel and the beach ball are like two circles touching an internal tangent, the balancing board. A central angle of a circle is an angle with its vertex in the center of the circle. Both legs of the angle are radii of the circle. An arc is an unbroken part of a circle containing all of the points between two other points on the circle. Arcs are measured by the central angle that connects to them. The spokes of a bicycle wheel are like diameters, going from one end of the wheel to the other. Any combination of these spokes will create central angles from the center of the wheel. A real-life example for an arc can be found in a rainbow. A minor arc has a central angle less than 180 degrees. It is expressed using the 2 points on the edges of the arc. Arc AC A major arc has a central angle over 180 degrees and is expressed using a third point in the arc ABC. A semicircle is an arc that measures 180 degrees exactly, where the segment between the two endpoints is the diameter. Dribbling a basketball is an example of a point of tangency. The point of the basketball which hits the ground is a point of tangency, tangent to the ground. A basketball court is also an example of a semicircle. The measure of the arc formed by two adjacent arcs is the sum of the measures of these two arcs. So you can basically add two arcs together. In this case, arc AB measuring 40 degrees and arc BC measuring 30 degrees can be combined into arc AC, which measures 70 degrees. In the same circle, or in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. This example shows congruent circles O and X, with two congruent angles, angle AOB and angle ZXY, both measuring 120 degrees. Arc AB and arc ZY are therefore congruent. With the relationship between arcs and central angles discussed, we can move on to the relationship between arcs and chords. A chord is a segment whose endpoints lie on a circle. Segment YZ is a chord because Y and Z lie on the circle. Here are two things about arcs and chords. In the same circle or in congruent circles, congruent arcs have congruent chords, and congruent chords also have congruent arcs. Arc TU is congruent to arc RS. Likewise, chord TU is congruent to chord RS. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. Diameter CD is shown here perpendicular to chord AB. Therefore, it bisects AB into two equal halves, AZ and ZB. Diameter CD also bisects arc AB into congruent arcs AD and DB. In the same circle or in congruent circles, chords that are the same distance from the center are congruent. Also, if two chords are congruent, it can be said they're the same distance from the center. Chords UV and RT are both the same distance from the center of circle Q. So chords UV and RT are congruent.